As a second example of a spherical coordinates calculation, let's revisit a problem that we did in an earlier video. The problem is to find the triple integral over q of y squared z dv, where q is the portion of the solid sphere of radius 2 in the first quadrant. We did this several videos ago using cylindrical coordinates, and we got the answer 2 pi over 3. Let's see whether what the problem looks like when we do it in spherical coordinates. So first of all, notice that x squared plus y squared plus z squared less than or equal to 4 is the same thing as saying rho squared less than or equal to 4, since x squared plus y squared plus z squared is rho squared. So this is rho less than or equal to 2. Now, of course, rho equals 2 is the sphere itself, but we want the interior of the sphere, so we're going to include rho going all the way from 0 to 2. So rho equals 0 is the origin, and then rho equals 2 is the sphere. So let's start substituting in, and then let's set up the bounds. We're going to use the formulas that we've memorized for spherical coordinates. Y is the same as rho sine phi sine theta. And that gets squared. Z is the same as rho cosine phi. And dv is the same as rho squared sine phi d rho d phi d theta. Now, in the next step, we'll simplify the integrand algebraically, but we can go ahead and set up the bounds. We already said that rho is going from 0 to 2. Since I'm staying in the first octant, I want to start on the z-axis, which is rho equals 0, and I want to continue downward until I get to the xy plane, which is going to be rho equals pi over 2. So rho goes from 0 to pi over 2. And lastly, theta is going to start on the positive x-axis, which is theta equals 0, and I want to continue around for pi over 2, 90 degrees, until I get to the positive y-axis. So to stay in the first octant, I need for phi to go from 0 to pi over 2, and I also need for theta to go from 0 to pi over 2. Let's simplify the integrand next. I have rho squared times rho squared, which is rho to the 5th. I have sine squared phi times another sine phi, which is sine cubed phi. I have a cosine phi. And I have a sine squared theta. Let's take a look at that, make sure that everything's accounted for. Looks like. So notice that, like in the previous example, all 6 bounds are constants, and the integrand is the product of a function of rho, a function of phi, and a function of theta. So I can factor this as the product of 3 different integrals. It will be the integral from 0 to pi of sine squared theta d theta multiplied by the integral from 0 to, these are pi over 2's, 0 to pi over 2 of sine cubed phi cosine phi d phi times integral from 0 to 2 of rho to the 5th d rho. So this last integral is just the power rule. The middle one is is a U substitution, and the first one is going to involve a power reducing formula. So let's maybe do some scratch work and figure out what each of these is separately, and then we can substitute back in over here. Let's start out with the first one, the integral from 0 to pi over 2 of sine squared theta d theta. The relevant power reducing formula says that sine squared theta is half of 1 minus cosine of 2 theta. So this integral will be half the integral from 0 to pi over 2, 1 minus cosine 2 theta d theta, which is half of theta minus 1/2 sine 2 theta, taken from 0 to pi over 2. Plugging in the two endpoints and subtracting, I'll have half of pi over 2 minus half sine pi minus half of 0 minus 0, since sine 0 is 0. Sine pi is also 0. So for the first integral, I'm just getting half of pi over 2, which is pi over 4. So the first of these three integrals is pi over 4. And next, let's figure out what the second integral is, the one with respect to phi. We have the integral from 0 to pi over 2, sine cubed phi, cosine phi d phi. Let's make the u substitution, u equals sine phi, so that du is cosine phi d phi. And notice that when phi is 0, u is sine of 0, which is 0. And when phi equals pi over 2, u is going to be sine of pi over 2, which is 1. So when I make the substitution, I now have the integral from 0 to 1 of u cubed du, which is 1/4 u to the 4th, taken from 0 to 1, or 1/4. So the integral in the middle is 1/4. And then let's do the third integral. The integral from 0 to 2 of rho to the 5th is 1/6 rho to the 6th, taken from 0 to 2, which is 1/6 times 2 to the 6th. That's the same as a third of 2 to the 5th, which is 32 over 3. So that means that the volume, it's not a volume, the integral we were trying to calculate is pi over 4 times a fourth times 32 over 3. And 16 into 32 is 2. So this is the same as pi times 2/3, which is 2 pi over 3. And that's indeed the same answer we got when we did it using cylindrical coordinates.